Hello everyone, in this video I'm going to show you how to calculate the optimum number of stages for your distillation column and also how to find the optimum fit stage. In the example that we did for the binary distillation system, we selected the total number of stages to be 21 and the fit stage to be 9 as the problem suggestion, and we are going to modify that, and it was one of the main questions in the problem statement to select a reasonable number for the total number of stages and also fit stage. One of the ways you can do that is to just try different numbers and check your results, and the other way is to working with shortcut column, which is useful when we don't have enough information to run the distillation column. It usually helps to find the optimum number of stages, fit stage, and also temperature of the condenser and reboiler. But you have to remember that it cannot be used instead of an actual distillation column. You just use the shortcut column to get the optimum number of stages, fit stage, and the temperatures. So we have to go back to your distillation column and modify your distillation column based on those obtained values. So for this example, let's try to use a shortcut column. So just go back to the model palette, and under the separator tab, add the shortcut column. It is located on the fourth row and it's in the middle. So click on the shortcut column and add it to the simulation environment, and also add a fit stream. And let's input the given information in the problem statement for the fit stream. If you remember, the feed was 100% vapor and the pressure was 1 atm and the molar flow rate was 100 kilomole per hour, and also the compositions, the 60% of the feed was dichloroethane and the rest was trichloroethane. So go back to your shortcut column and double click on that, and you can see again the design window for this column. So select feed 2 as the inlet, choose a Q different name that you choose for your main distillation column, like Q1 for the condenser duty, distillate rate D1, reboiler duty Q2, and bottom B1. So after entering these informations, just go to the parameters on the design tab, and let's add some information to run this shortcut column. So the light key in bottom is the dichloroethane, and the heavy key in the distillate is trichloroethane. And we know that we want the mole fraction of the dichloroethane in the bottom to be 0.08 because we need 92% trichloroethane, so the mole fraction for this component should be 0.08, and also we want 92% of dichloroethane in the distillate, so the mole fraction for the trichloroethane should be again 0.08. And we know that the operating pressure for the condenser and reboiler is equal to 1 atm. So put 1 atm for both of them. And also we know that the reflux ratio should be equal to 2 based on the problem statement. After entering these numbers, the unit will be converged and we can obtain some useful information from the results of this unit. So go to Worksheet tab and you can see some values for your streams, and then go to Performance tab, which is the main goal of using a shortcut column. You can see that actual number of frames is almost 14 and the optimal fill stage is 6.2. You can see the temperatures for condenser and reboiler and other information about the flow rates and the amount of heat or energy that you need to run this distillation column. So using these values, let's go back to our main distillation column and put these values and run our distillation column again. Double click on your main distillation column and change these numbers based on the values you obtained from the shortcut column. So changing these values, hit run again, and you can see the results again in the Worksheet tab. So go to Compositions and check if we have reached our goals. So you can see we have dicolor attained the molar fraction of 92% and 9284, and also this number is also higher than 92%, and comparing with our previous results, they're closer to our targets, and with a lower number of stages and also lower amount of duty, we have reached our goal. So we have saved a lot of money. So a shortcut column can be used to run a distillation column optimally and don't waste money and energy. So you can use this shortcut column in obtaining the results and going back to your distillation column and modify your distillation column, design a specification and information to obtain a better result. Thank you, and let me know your questions.